All right, guys, final page. Let's rock. 4 divided by 2/3. Don't like it. Okay, it's like I got 4 candy bars, splitting it up, passing out 2/3 at a time. What's going to happen? Can't do it like this. So I first say, turn them both into fractions. 4 over 1 divided by 2/3. Again, both methods. I can't just go straight across. And again, that like super trick, you can say, all right, 2 over 1/3. Well, what do I need to do to get this to a whole times 3? So times 3 times 3, I'd get 6 over 1. So I'm sure it's 6. But that's not for everybody. If I say, first I'll multiply by the reciprocal. So 4 over 1 times 3 over 2. Let's see, that gives me 12 over 2, which would be 6 wholes. Back to this look, I want to turn maybe both into 3's. So to get to a 3 in the bottom here, it's times 3, so top times 3. I'd end up getting 12/3, and then when I divide that by 2/3, I'd have 6 on the top and then 1 on the bottom again. So all 3 of those ways I'm getting 6. That's my final answer. 3/5 divided by 6 can't do it, so I'll rewrite first. 3/5 divided by 6 over 1. Now I can't do it. I could, again, just because I can't help myself, if I wanted to, I could say the top becomes a half and the bottom becomes 5. And then if I divide this by 5 and that by 5, I know it's going to be, I think, 1/10. But we'll just go the older way. Multiply by the reciprocal version is 3/5 times 1/6. That's going to give me 3 over 30. And that goes to 1/10, dividing the top and bottom by 3. Common denominators, you'd see it's going to be like the same thing. We'd say get them both to 5 in the bottom here. So times 5, that becomes 3/5 divided by 30 over 5, which is something over 1. It's 3/30 over 1. Okay, which then we would reduce to 1/10, just like up there. So 1/10. 7 times 3/5, put it over 1, go across. 7 times 3, 21. 1 times 5, 5. I swear we saw this on one of the other pages. We end up with 5 going into 21 4 times with that 1 left over. 4 1/5. Okay. Next, these ones are extra credit. Go for them if you can. I crossed this one out. There was something a little bit off with it, and then rewrote something similar. This is a tricky one. Cross-reduce. One thing about cross-reducing, okay, and I'd kind of taken it for granted. I don't know if it came through in class. It's only multiplying. Only multiplying. Okay, and so you notice, oh, this one's division. That's not going to work. No, it still will, but don't do it while it's dividing. You can do it while it's when it's multiplying. Anyways, I'll start off with this one. We're looking for things that the opposite numbers have in common. So 30 and 15 are, those, I think of the clock, right? Quarter hour, half hour. So what I know is that this is double that. So I can actually reduce this down and watch what I'll call it. I'll call it 2 to 1. 30 to 15 is the same as 2 to 1. If I divide them both by 15, I'm going to get 2 and I'll get 1. And 5 and 40 are related. If I divide them both by 5, this will become 1 and this will become 8. So the reason we want to do this with multiplying specifically, like if I didn't do this, I would end up with 150 over, 600. And, yes, that's not as too bad to reduce down, but this is a lot easier. What's 2 times 1? 2. 8 times 1? 8. And can I reduce those again? Yeah, they're both even, so they become 1/4. And you might see that here. You can get rid of both those zeros, divide them both by 10. 15 over 60 is that same clock analogy that I gave before, 1/4. So this one was interesting. Okay, I got this mixed number, so I'm going to change it. 55 plus 5 is 60. Keep it over 11, divided by 30 over 44. Now I just said I can't do it with anything but multiplying. Okay, so with that reciprocal method where I say multiply by the reciprocal, so keep the first, multiply by the reciprocal. Okay, now I'm going to have, 60 and a 30. Well, that's a double relationship. Divide them both by 30, 2 and 1. And 44 and 11, well, that's divide them both by 11. This becomes 1 and this becomes 4. So weirdly, 2 times 4 is 8. 1 times 1 is 1. So that goes all the way to say 8's our final answer for that. You know, I'd say grab a calculator, double check, man. I feel like that one's weird, but let's stick with it for now. Why not? Fred has 36 yards of rope. Notice that's his total. They told you straight up. And he's going to go to a camping trip where he's going to make that smaller, and he's going to make all these pieces that are this size. So that's telling us we got to get to 36, and we're going to be going by 2 4/7 at a time. Now this could be a pain, right? If I know this is 2 4/7, do I really want to go to the next one and say it's 4 8/7, so it's like 5 1/7? Do I want to do this weird adding of mixed numbers this whole time? No, I want to find a shortcut. First, write out the expression. It's going to be 36 divided by 2 4/7, saying how many 2 4/7 can fit into 36. So I'm going to say that, let's do that. Let's change this to an improper first. So this becomes 14, 4. It becomes 18/7. So I'll put that right underneath this stop. And if I want to do the next one to get me to 36/7, I'm going to do a super cheat here and say, all right, how many times can, if I did 36 divided by 36/7, is that, oh, I'm sorry, not 36, 18/7. Okay, good. Whew. Starting to lose my mind here. Okay. One of them, I'm getting too far ahead of myself. So if I say 36 divided by 18/7, put it over 1, okay? And then I'm going to do the reciprocal. So I'll say 36 over 1 times 7 over 18. And then I'm going to shave these guys down, right? Those are related. 2 and 1. 2 times 7 is 14. 1 times 1 is 1. I have that method. And then really what's interesting is we kept talking about turn this into something over 7 too. That's the exact same thing as the common denominator thing. And maybe your answer will jump out at you that way. So 36 at first becomes 36 over 1, which then becomes what over 7? So I got to say 36 times 7 over here. And this is some exploratory math. Like, I'm sorry that I'm jumping around here. Typically I would say just jump until you get there, but I like to see all these different ways to think about it. 7 times 6 is 42. 21 and 4 is 25, so 252. So my 36 is the same as 252/7, and I'm jumping 18/7 at a time. So what I might do is shortcut it again to say 252 divided by 18. That should give me my same thing. Over here I got 14. Let's see if this gives me 14. 18 and 2, no. 25 just once. Minus my 18, I'm going to get slowly here, 7. 18 plus 7 is 25. Bring that down. 18 into 72. Guess and check to the side. 18 times 3, that's going to be a 4. A 2, that's 54, so I can try another 18. Let's add another 18 here. I'm going to get a 2, carry that, 72. There it is. So how many 18s? It's 4. So 4 18s gave me another 72 perfectly. Okay. Back to this style. I mean, I guess this is why you'd want to do it, because do you want to, I don't know which is easier, to keep going by 18s, 54 over 7, 72 over 7 until I get to 252. It's kind of gross, so I kind of hosed you guys on this one, didn't I? But you get the gist, ideally, that you're going to have to keep going. Hopefully you've got the patience. Maybe skip. One thing to do is maybe look for a nice, if you get to 9, then you can just say however many it took to get there, multiply by. I have a feeling you won't get to 9. I have a feeling you'll get to 18. Like 7 of these things will get you to 18. Anyway, that's the math behind it. That's the reason I got this video. So I'm going to run out of time here too. Should have just done it, right? Boom. 72 plus 18 is what? 90 over 7. And another is 108. I'm just going to stop. Okay, you guys get the idea. Okay? You will not have something like this on our test. I'm not that mean. Shelly knows her friends love pizza. Gonna have 13 come over, and they're each gonna eat 5/8. You have two options. You could say like 13 fives or 13 5/8. Either way you want to, if you do the 13 fives, you have to divide by 8 because that's how many are in a pizza. So I'm going to do this one the right way. Is this division? No, because they're asking me how many pizzas do I need overall. So I'm going to do this 13 5/8 thing. So the good news is we're going to skip count by 5/8, and that's a lot easier than 18 sevenths. So 0 to 5/8 is 1, and I'll say there's 13 total jumps, so I'll do that now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So whatever I have here is my answer. So 5/8, 10/8, shortcut it a little bit. 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. So again, those are all over 8, okay? Go back through and put 8 underneath all of them. So 65/8, let me do that as division. 65 divided by 8. Man, knowing your times tables are great because I know 8 times something gets me really close to that. 8 times 8. Okay, I don't put it here. That's over the 6, right? This is really important. 8 goes into 65 8 times because 8 times 8 is 64. Subtract, and I have 1 left over, and I'll bring that up, and so I have 1 over 8. So 8 1/8 is my almost final answer. I got to go back to the problem. That's why this parentheses thing is here. Is it a pizza place I call up Domino's? Are they going to sell me 8 1/8 pizza? No. So really my final answer has got to be 9. That's a great word problem that you'll see like on that end of the year test where they're going to assess like, are you thinking about the whole picture? Can you do more than just calculate stuff? So you need 9 pizzas to pull this off. Can't help it. I got to look back up at this one before, what did we say? It was 14, right? So in case you're still wondering, you're like, what is he talking about? 14 pieces was your final answer, the final number of jumps you'd have there. Read this carefully or you'll be incorrect. JJ runs a parking lot outside of the Broncos Stadium. He saves a fifth. And we have this model too. We haven't done this in a while, but this is the fraction multiplication when two things are less than 1. So he has 1/5 of his lot for large trucks. So I'll do this right now. 1, 2, 3, 4. Split it into fifths. And that means this part is for the large trucks. Okay, and then 2/3 of this space is empty. Well, let me go ahead and set up my thirds and then shade in 2/3 of all of it. And then I look kind of like for what's double shaded. Now, the reason I say be careful, and this is one of those at the end of the year as well, is because the question doesn't say how much is empty. This fraction tells me how much is empty, but then the question says what fraction of the lot is filled with large trucks. So looking back at it, this whole swath was for large trucks. This part is empty, meaning the opposite of empty is this part. This one single piece is full. You got all these little trucks and large trucks in here, right? Nothing in here. And so if it says what part of the lot is filled with large trucks, even though this is double shaded, I have to add meaning to what I just did. This is what they want to know, just this one section. How large is that compared to the whole lot? 1 out of 15. And that's our answer there. 1/15 of the lot is filled with trucks of the lot. Okay, this one's looks wild, and it is kind of wild. We got a little order of operations and some wild mixed number stuff. So we've got to remember, we had tried PED this year to say how we need to do things. So parentheses, this is only in parentheses so I could show you this exponent. It'd look really weird if I didn't have that there, if I had a 2 like in there, right? So I don't really have a parentheses, but our E exponents, we do have one. So my first thing I'm going to do is 2 1/4 times 2 1/4. That's going to be 9/4 times 9/4, right? I have 2 of those multiplied. So the top is 81 and the bottom is 16. I am going to leave it like that for now. Okay, so this becomes 81/16. Gone. So are there any more exponents? No. All right, next is difficult operations. Don't forget left to right. So this, no, but this is key. So I need to multiply these two numbers first. I don't care about that part, just this is first. So let's see if I can pull this off. That's 12, and 2 more is 14. So I have 14 over 3. And I am going to cross reduce here, multiplying so I can do it. So I've got 14 and 16. They can go down to 7 and 8. Divide them both by 2. And 8 plus 1 is 9, so I know it's divisible. And I had done this before, so I got to cheat. But 81 divided by 3 is 27. So this becomes 1. This becomes 27. So I know 7 times 27, whatever that is going to be over 8. So I'll do that over here because I don't remember that. It's going to be a 9, a 4, 14, and a 4 is 8. So I got 189 over 8 right now for this. Okay. I'm going to leave it like that for the time being. So this is gone now. So is that. 3 1/5 plus 189 over 8 minus 7 2/5. Actually, I'm going to go ahead and convert it because I know that if I'm going to add it, it's easier to just do it wholes and then the fraction. So 189 divided by 8. 8 into 1, no. 8 into 18 twice because 8 times 2 is 16. I have 2 left over. 29. 8 goes into 29 3 times because I'll have 24 with 5 left over. So 23 and 5/8 is what that just became. Okay. If you need to use a different area, feel free. So now I'm going to look at this 7 2/5 divided by a third. I hope this is easy. 35 and 2 is 37. So I have 37 over 5 divided by 1 over 3. I'm going to multiply by the reciprocal. So I have 37 over 5 times 3 over 1. So again, come off to the side for that hard stuff. I get a 1 and a 2, 21. 9 and 2 is 111. So I got 111 over 5. I'm going to change that back to a mixed as well so that I can better use it. So 111 divided by 5. 5 into 1, no. 5 into 11 twice. Minus 10, I have a 1. Bring you down 5 into 11 twice again. And I have 1 left over that 5. So to rewrite this whole thing, I'll use the back of another sheet of paper. Jeez, this could get, this is why it's the hardest one, right? The last one, the mega. So I have 3 1/5 now, plus 23 and 5/8 minus 22 and 1/5. Okay, and you'd be surprised how many of you guys can do this if you're patient and you stay organized with your thoughts. So I'm done with my difficult operations. Now I do easy ones left to right. Okay, so 3 1/5 plus 23 and 5/8. 8 and 5, not going to cut it. Need them both into 40ths. Okay, so what I'll do actually is 23 plus 3 is 26. Put that over here, 26. And so 1/5 becomes what over 8? 5 and 8 is 40. So I need something over 40. So 8 times 8, so 8. 1 times 8. And then 8/5 become, 5/8 becomes times 5 times 25. So add these together. 8 plus 25 is 33. So good, I didn't get a new whole. So I have 33 40ths. So now those two are gone, and I have minus 22 and a 5th. All right, so I am going to change this first. I want to see what this is as 40ths. And I actually know from there, 1/5 already, I did 8 40ths. Okay, so I'm going to say, rewrite it as 26 and 33 40ths minus 22 and 8 40ths. And I'm in great shape. This is like time, right? If I had, we did this a while back, Monday before all that snow, if I had, 815 minus 240, that's hard. I'd have to like regroup this, figure out how many minutes this is. We had said that'd be 7 and add 60, it'd be 75. But if it's 840 minus 215, I don't have to do that. And so sure enough, big minus small, we're in great shape. 33 minus 8, I'm actually going to go back to that 25 40ths. So you can do that first and say, all right, I have 25 40ths, which I'll reduce in a second for my fractional part, and then 26 minus 22 leaves me with 4. So 4 and 25 40ths, these are both 5, so divide by 5 is 5, divide by 5 is 8. So I'm left with 4 and 5/8 for that final answer. Wow. pretty wild. So 4 5/8 here is what you end up getting after all this madness. So if you did that, excellent, guys. You are a trooper. So if there are still questions, feel free to email me.